Have you ever wondered how modern enterprise applications stay in sync without any tight coupling between their components? Imagine you have an online e-commerce store. When a customer confirms an order, the order system needs to notify the shipping system to start the shipping process. You can't just update the shipping aggregate directly from the order aggregate because they are in the separate transactional boundaries. So how do you handle this type of communication between two different aggregates? In this video, I will show you exactly how the domain events are used in the domain-driven design to communicate between different parts of an application without creating tight coupling, allowing components to react to changes. My name is Vakas, and in this video we will explore what the domain events are, why they are essential for building scalable applications, and how you can implement them in your projects. Whether you are working with microservices architecture, modular monoliths, or any other type of distributed systems, the domain event will revolutionize the way you think about the components communication. A domain event is essentially something significant that happened in your business domain that other parts of your systems need to know about. Think of it as a notification system for your business logic. Domain events are always defined in the past tense. For example, dinner created, invitation accepted, booking submitted, order created, and so on. In the context of domain-driven design, aggregates are designed as boundaries of consistency. This means that the changes within one aggregate should generally not directly impact another aggregate. We call this cross-aggregate changes a side effect. The domain events are designed to handle these side effects within the same system. The beauty of domain events is that they capture the language your domain experts actually use. When a business person says when an order is placed, we need to notify the customer and update inventory. These are basically your domain events. Let's cover some of the key benefits of domain events. The first benefit is the loose coupling. Domain events allow different parts of the system, such as aggregates, to react to changes without being directly aware of or dependent on each other, which means one aggregate can react to events or actions happening inside another aggregate. The next benefit is the separation of concern. Domain events separate core domain logic from the side effects, allowing side effects to be handled asynchronously and usually in a different transaction scope. Next, domain events improve the maintainability of your application. Adding the new actions or features become much simpler as new event handlers can be added without changing the original code that publishes the event. Domain events can be handled asynchronously, which improves performance and scalability of your application by not blocking the initial request. Domain events also make your application resilient. By decoupling the components, if one part of the system is temporarily unavailable, the event can be queued and processed later, preventing a complete system failure. Domain events are also the key mechanism for achieving the eventual consistency across different parts of the distributed system. I have created a new solution in .NET 9, and in this solution I have three projects. The first project is the domain project, in which I will create all my domain entities. The second project is an application project, which can have a CQRS queries and commands and all the business logic need to run the application. The last project is a shared kernel project, in which I can define all the shared classes or the base classes required in entire project. The first thing I'm going to create is a marker interface that will define all my domain events in my project. So let's call it iDomain event. Next, I'm going to create an abstract class that's called aggregate root. This class will act as a base class of all the aggregate roots in my project. Inside this class, I'm going to create a private list that will hold all my domain events. Let's initialize it with the empty collection. Next, I need to create two methods. The first method will be used to add the domain events from any aggregate root that will inherit this aggregate root base abstract class. So let's call it add domain event. And inside this method, I'm simply adding the domain event inside my private domain events collection. The next method I need is to clear all my domain events from any aggregate root. Let's say I'm creating a content management system. I have a domain entity called post, and this entity has basic properties such as post ID, title, posted date, contents, and there are few private constructors which can be used to create the post object internally. There is also a public static create method that will be used to create the post objects. Because the constructors are private, so this create method is the only way I can create post objects from outside. There are also few methods to update the post title and the post contents. Now to make this class an aggregate root, I need to inherit this class from aggregate root abstract class. So now this class will act as an aggregate root and it has all the functionality available inside the aggregate root, which means now inside the post class we can call the method such as add domain event to raise any domain events. To raise the domain events, we need to first define some of our events. So let's say inside my content management system, I need events such as post created domain event or post updated domain events, which I want to raise from these methods so that every time these methods are used, I can notify other parts of my system that the posts are created or updated. Normally, I create an events folder to create all my domain events related to any domain entity. In this case, our domain entity is a post. So inside this post folder, I have created this event folder. Inside this events folder, I can now define some of my events. For example, post created domain event. This event will be public, sealed, and I can create it as a record because records are immutable. The next thing we need to decide is what information we want to pass inside the domain event. So let's say whenever the post is created, I want to pass the post ID and the post title inside this event. Every domain event inside our project need to implement that iDomain event interface we just declared. Similarly, we can also define another event which is the post updated domain event. This event will be similar to the previous event and I can pass the same information post ID and the title inside this event. Now we can raise these events from our aggregate root. We know this constructor will be called every time the new post will be created. So this is the perfect place to raise the post created domain event. I need to call the add domain event method, which is available from the abstract base class. And inside this method, I can pass a new post created domain event. We know that this domain event need ID and the title of the post. And we have this information available because we are already inside the post class. In similar manner, we can also add a domain event from inside this update title method so that every time the post title is updated, we can raise a post updated domain event. Same event can also be raised when the post contents are updated. Next, we need to create some domain notification handlers that can have all the code we need to implement the side effects of these domain events. Let's create our first event handler inside the application project. Let's call it post updated domain notification handler. As a good practice, I'm also creating this class as a seal class. This class will implement the iNotification handler interface, which is available inside the Mediator package. So don't forget to add the Mediator package inside the project. Here inside the iNotification handler, I need to pass the domain event I want to handle from this notification handler. In our case, it's a post created domain event. Now we are inside the handle method and this method will execute every time the post created domain event will be raised from the post class. Let's say I want to send an email notification from this handler. I already have a class iEmail service in my project. So let's inject this class. And here we can call the email service method send email. The send email method need from to subject and message as a parameter. So for the simplicity, let's pass this information as a hard-coded emails. The subject can be post created or new post created, and a message could be a new post is created with ID and title. Inside this handler, we have access to the post created domain event. So from this notification variable, we can access the information passed to us from inside the post class when the domain event is raised. For example, here I have access to the post ID and title, because this is the information we passed inside the post created domain event when we raised it. The reason we are getting this error is because we are using the Mediator interface iNotification handler, and the object we pass inside this iNotification handler is not an iNotification type object. To fix this, we need to implement the iNotification interface on top of the iDomain event interface. This iNotification interface is defined inside the Mediator package. Now you can see the error is gone. Let's recap what we implemented. Inside post aggregate root, we are raising domain events such as post created domain event or post updated domain event, and we are also defining the handlers which will handle specific type of domain event. And here we can run the side effects of domain event. Domain events are a powerful pattern to implement scalable and maintainable applications. They help you achieve loose coupling, better testability, and more extensible architecture. If this video helped you understand the domain events, smash the like button and subscribe for more software architecture content. Until next time, stay awesome.